Hi everyone, this is a short video to explain question 5 on power. So this is question from page 20 and I'm going to work through this question 5. Okay, so oops, got pointed at the wrong question. It's this one here with the lamps. Okay, right, so now, just read the question. So, in the circuit shown, each lamp has a resistance of 10 ohms. So, that's your circuit. Now, calculate the total resistance of the circuit. Now, when you're given a question like this, you've got things in parallel, you've got things in series, there are all sorts of things happening. So, the easiest thing to do is you're going to find the effective resistance of B and D. Okay, so what can you replace these two with? And then you add it in series with C, and then you're going to get one number for here, and then these two are in parallel with each other, and then we use the parallel formula. That's right. Okay, so step 1 is this is E. Total resistance of B and D. That's what I'm doing, just those two. So in order to get that, I do 1 over RT is equal to 1 over 10 plus 1 over 10, okay? Or RT is equal to 10 to the power of negative 1 plus 10 to the power of negative 1. And then you put that in your calculator and you're going to get half of this, which is 5 ohms. So these two can be replaced by 5 ohms, okay? Then the next step is what's the total resistance of B and D? We know that's 5, and C as well. So that's 5 plus 10, okay? So that's equal to 5 plus 10, which is 15 ohms. And then now you're going to find the resistance of the whole thing. Now it's like A is in parallel with this 15 ohms. Okay, so total resistance of the circuit, that's A plus B plus C plus D. Okay, so you go 1 over RT is equal to 1 over 10 because they're all 10 ohms, but that totally is 15 plus 1 over 1 over 15. So you're going to get a number which is smaller than 10, isn't it? Okay, or your RT is 10 to the power of negative 1 plus 15 to the power of negative 1. Okay, so let's see what that gives us. So open brackets, you go 10 to the power of negative 1 plus 15 to the power of negative 1, close bracket to the power of negative 1, and I get the answer 6. Okay, so the answer is 6 ohms. So the total resistance of the circuit is 6 ohms. Sounds about right because it has to be a number less than 10. Okay, moving on. The brightness of a lamp depends on the power it uses. An identical lamp E is connected in parallel with D. Okay, so what happens? So I'm just going to do red. So they're going to connect one more lamp E over here. Okay. Then, by considering what happens to the voltage across and the current through, remember those are the terms we use in physics, we say voltage across, current through, explain what would happen to the brightness of lamp A. Okay, so the voltage across A will be the same as the supply voltage because these are different branches, right? Okay, and the resistance of A hasn't changed. So the current through A is going to be the same. So the brightness of A is going to be unaffected by adding another lamp in parallel over here. All right, so that's the answer to that. Then explain what will happen to the current from the battery. Now, so we've talked about A, but what's going to happen to the current drawn from the battery? Now, because we've added one more in parallel here to this branch, so the effective resistance of this thing is going to be less. Okay, so that means the total resistance of that branch is going to be less. It's not going to be 15, it's going to be a number less than 15. It's going to be less. So the total resistance of the whole circuit is going to decrease. It's going to be less. So if the total resistance of the circuit decreases, the current drawn from the battery is going to increase. You're going to have a bigger current from the battery. Okay, then D, by considering what happens to the voltage across and the current through, explain what would happen to the brightness of lamp C, B, and D. Okay, let's take this one at a time. So now what's happening is you've got a bigger current coming through. The larger current because of adding this, but it's the same one that went through A initially that goes through. Okay, so it's a bigger proportion here, but when it comes to this junction, this current splits into three, right? And then you have them all joining up, and this whole larger current is going to go through C. So the addition of E will mean a bigger current through there, as well as the whole current, it all meets up. Okay, so a bigger proportion of the current goes through C. So C is going to be brighter because it's going to have a larger current as well as a bigger voltage across it. So C is going to be brighter. What's going to happen to B and D? So what's going to happen to B and D is that because the current is split into three, it's going to get a smaller proportion of the current compared to before. But because they're all in parallel, the brightness of these three will be the same, but they will glow less brighter than before. Okay, so that's the answer to question number 5. And I hope that made sense, and I hope you understood. So bye for now.